Okay, percent error problems. Notice on here we're going to show all our work and round to the nearest hundredths and put your answers in a percent. So here's our formula. Percent error. Accepted, or what we call the known value, the teacher said, the book said, you know this value, minus the experimental value. Somebody did an experiment in the lab and got this value, divided by the accepted, or the known value, times 100. Okay, when you see these little signs here, that's an absolute value, meaning we're going to ignore the negative signs. Okay, so let's look here. Density of water at 4 degrees is known to be 1. So there's your known value. Kayla experimentally found the density of water to be 1.15. So that's the experimental value divided by the known value. Again, the known value is 1. Ignore the negative signs, times 100. So we're going to put that in the calculator. So of course we'll get 0.15 divided by 1. Okay, so we'll get 0.15 times 100. So that's 15% error. So what that means is from the real value, your experiment was 15% off. Okay, so you're going to do that same thing for number 2 and number 3. When you get to number 4, notice we have a set of values. Okay, so the first thing we need to do is we need to take an average. But all of these are 75, so the average is 75, right? So that's going to be the experimental value. It says the reference books finds the actual value to be 78. So there's the known value, there's the experimental value. So you're going to plug your numbers into this formula again to get your percent, and then you're going to decide, is it accurate or precise? On 5 and 6, notice all of these values aren't the same. So we're going to get an average, meaning we're going to add these 4 values up and divide by 4. Here we're going to add these 5 values up and divide by 5 to get the average. So those will be the experimental values to plug in for your percent error. Let me know if you have any questions.